it should be. They should be replications of the ones that we just did up here. Just with inequalities in there.
Wait, are these?
So these are corrected. These are, yeah, notes. But we're dealing with parabolas again, but we're making them inequalities.
Okay.
So inequalities means I have to do what? Shade. Right. This is inequalities. And that implies shading. And with my parabola, I have only two options, just the way I had options with absolute values, either inside my parabola or outside. And I've got to be careful. My parabola is either going to be a dotted or a solid line. And we know that the dotted is because it's strictly greater than or less than, right? Just like our lines, correct? When we did our inequality of our linear functions, we made them dotted if it was strictly greater than or less than. We made them solid if the equality was in the problem, as in this one. Okay? So we know from above that we have 0, -4 for this first one, right? We're just using the same information instead of regenerating another parabola. We're just doing the same parabola again. What did we say the vertex was? -3/2, comma, -25. And then the reflection point was -3, comma, -4. Is that right? I'm doing this from memory. So -4, 1, 2, 3, 4, 0, 3, 0, and what did we say this was? 6, 4, 5, 6 1/4. So right here. Now, is this going to be dotted or solid? Okay. And here's what I want you to do. And the reason I want you to do this is kind of is because we're going to be putting two of these parabola inequalities together. Don't make your tails go straight up. Exaggerate them after your 2 points and really make them go out. Because we want to see where, when we put two of these inequalities together, where the parabolas are intersecting. Okay? So kind of really exaggerate. That's probably not what it looks like. It probably is a little more curved, but just exaggerate those tails going out. Okay. Just like with our linear equations, where do we place our pencil? On the y-intercept. And we travel either up or down according to our inequality. This inequality says what? That means are we inside or outside? You've just now graphed your problem. So if you know how to do your absolute value inequalities, these are relatively the same manner. It's just for a parabola. Does that make sense? Uh-huh.
So are we still not all the same all the time, so we still have to like unify steps?
You don't. Basically what I'm looking at in this case is I want my vertex, I want the y-intercept, and I want a reflection point. Okay? I don't need my axis of symmetry. I don't need the direction, although I think maybe it would be helpful if you did keep the direction in mind. Okay? All right, we said that this one had points of 0, 0, and, oh, let's make this plus so that it's the same as the other one. -4, 0, correct? Y'all with me? This is just from the previous problem up above, yes? And just change that to a plus so we don't have to regenerate all the same information, because I think I was guessing what the problem was. Y'all with me on this? Okay. And then what did we say the vertex was? -2, comma 4? Yes or no? Okay. So we're at 0, 0, 1, 2, 3, -4, 0, and -2, 1, 2, 3, 4. Is this a solid or a dotted? Why is it solid? The equal sign in our inequality, right? Notice my arrows at the end. They go on forever. Put your pencil on the y-intercept. Travel either inside or outside my parabola. Which way am I traveling? Inside. What would it need to be if I wanted it to shade on the outside? Exactly. Are we good? Any questions? Okay, let's do the next one. So this is the same problem, right? I'm going to make this one plus, both of these plus. And so we know that this is 0, 0, and -4, 0, and -2, 4. I'm just trying to give you some options of what this is supposed to look like, okay? And so 0, 0, 1, 2, 3, -4, 0, -2, 1, 2. Solid or dotted? Solid. Inside or outside? Outside. Because I want greater than. Greater than means I'm going up my y-axis, which takes me outside my figure. Are we good? All right, we're just going to skip this one. All right, so now we're going to put them together. Now we're going to put them together. And all you're doing is graphing two parabolas individually and looking for the overlap of shading. That's all we're doing. Okay? So the first one, that's going to tell me, we did this one before, didn't we? This is 0, 0, and 0, -4. No, this is a different one, isn't it? This is a different problem. All right, so let's look at it as if it were equal. Y equals -x² plus 4. Did we? Oh, is that the same as this one? No, this one has an x in it. Oh, this one doesn't. Okay, this is the no-b method. Remember the no-b method? Okay. Y-intercept is at 0, 4. We know that it points down. -b/2a gives me my value for x, which is going to be 0 over -2, which is 0. And remember, this is where the y-intercepts and the vertex are the same value. Remember this? So 0, 1, 2, 3, 4. And then this is the case where we generate a point and reflect it. And does it matter what value I let x be? So I'll use 1. And if x is 1, I'm going to get 3. Which means at -1, I should get 3 also, correct? Is this going to be a solid parabola or a dotted parabola? Because we've got an equality. Make them exaggerate the bend, you know, the curvature, okay, your tails. All right, for argument's sake, where am I shading? Inside or outside this parabola? The inequality states less than, right? Less than means down, down means in. So we know that currently for this one we're inside. So let's do the next one. Y equals x² minus 2x minus 3. Standard form, points up, 0, -3 is my y-intercept, and negative b over 2a gives me an x value of 1, yes? And the corresponding y value will be 1 minus 2 minus 3, which is -4. So 1, -4 is my vertex. You following the math? So at 1, -1, 2, 3, 4, in which direction does this point? And 0, -3, and the reflection then is 2, -3, right? And then is this solid or dotted according to the original inequality? It is dotted. You've got to show me that these two parabolas intersect. And where is the shading for the second one? Up. So we're down or in and up or in. So that means our answer is right in between those two parabolas. So again, the one that points down was inside, yes. The one that points up is inside. So where is the area that's inside for both? That little area right there. If double shading helps, then do double shading. Okay? All right. Olivia, you good? Because you had some frowns going on. What is bad about the graphing? Yeah. I guess the only way I realize that is y has a tail, and the tail is up and down. I don't know. Something to think about. Okay? All right. You try those. Let's just do a couple of them. Let's try, you do A, please, and this one right here. Let's try those. You want to work next to somebody so that you're doing it with someone? That's fine. Okay. Do them. Scoot next to somebody if you'd like. The y-intercept, no, the y-intercept is 0, 0. Look, 1, 1, Sarah, is right here. That can't be a y-intercept.
Yeah, that's what I'm saying.
Yeah.
That's the vertex.
No, Sarah, there's the vertex right here. Negative b over 2a. X equals negative b over 2a. That's 0. So when you plug in 0 into here, you get y equals 0. That's your vertex. Right here.
Yeah. Which one do you change?
What do you mean, which one do I change?
The line lines, because there's
Okay, I don't have a y-intercept. This is the no b method. If I don't have two separate points at this point, I have to generate a point and reflect it. The no b method has the vertex and the y-intercept being the same.
yeah, okay, that's
So then we generate a point. I generated 2 and negative 2 as my x values because I was too close down to my vertex. Okay. All right. Casey, if you gotta go, you gotta go? No.
yeah. And I just have a question.
Uh-huh.
It never cross.
Exactly. So that's why there's no solution, because you're right. No mixing of shading is a good way to put it. Okay? All right. Let's try the next one. Now, this is the same problem. This is, however, what do you notice in this? Well, what's missing in this inequality? There's no y variable. This is a single variable equation or inequality. Okay? So what we want to think, though, is we want to think in our head, this is still a quadratic. This is still a quadratic. All right? And what I'm looking for is, this is going to be values of x that are going to make this true. These are going to be inequalities, and you'll have two solutions. So the chart method. In the chart method, you want to find your zeros by first factoring. Well, if I'm going to factor, I have to have everything on the same side of the inequality, and my equation or inequality has to be set equal to, therefore, we're looking at this as x squared plus x minus 6 less than or equal to 0. All right, factoring should be a no-brainer. X minus 2x plus 3. That means my zeros are at 2 and negative 3. Agreed? All good so far? Okay, so here's what the chart looks like. This is my x, this is my y. I have two zeros. We're going to put them in numerical order. Negative 3 is to the left of positive 2. Notice how I have spaces in between. Our spaces are our test points. Okay? If I plug in negative 3 into my inequality, what should I get? If I plug negative 3 back into this inequality, what should I get? Remember, we solved for the zeros, didn't we? So what should we get? 0 here and 0 here, yes? Well, I mean, we set them equal to 0, didn't we? Aren't these solutions that make them 0? Now, I want you to pay attention. This inequality, what kind of answers am I looking for? Positive answers or negative answers? I'm looking for negative answers. That's what I'm looking for. Okay, so we're going to put some test points in. Give me a value to the left of negative 3. Negative 4, negative 5, negative 6, negative 100. Many choices. Negative 2 is not. Yeah. Okay, but what's a great value between negative 3 and positive 2 that you really want to use? I would use 0. If I can use 0 at any time, it's a perfect value to substitute in because it drops out your terms. Give me a value to the right of 2. 3, 4. I like to stick close by. I don't want my numbers to be too big because then my substituting answers get really big, okay? So, remember, I'm looking for negative answers, right? Okay, so at x is equal to negative 4, I'm going to get negative 4 squared plus negative 4 minus 6. Is that less than or equal to 0? That's the question. Well, this is 16. This is minus 4 and minus 6. So all of this is 6. Would you agree? Is that less than or equal to 0? Nope. I don't want this. I get a positive answer. I don't get a negative. Remember, I'm looking for negative values, right? So now let's look at 0. Let's let x equal 0. If x is 0, I get 0 plus 0 minus 6. Is that less than or equal to 0? Absolutely. I get a negative value here. That's good. And then we try when x is 3. Well, that's going to give me 3 squared plus 3 minus 6. Is that less than or equal to 0? 9 plus 3 minus 6 is not less than or equal to 0. It's a no. So basically what I'm looking for are all values that fall between negative 3 and positive 2 are going to satisfy that original inequality. And so here's how we write it. Notice that it is less than or equal to. So x falls less than or equal to 2 and greater than or equal to negative 3. This is an and statement. Between my zeros are the good values. On the outsides of my zeros, they don't work. I get positive answers. I don't want positive answers. I want negative answers. So I could have tried negative 2. I could have tried negative 1. I could have tried positive 1. All of those are going to give me values that are less than or equal to 0. But as soon as I go to the other side of 2, 3, 4, 5, those give me positive values. And as soon as I go to the left of negative 3, negative 4, negative 5, those again will give me positive values. Because if one test point fails, all of them will fail. And if one test point works, all of them in between those zeros will work. Emma?
So if the original statement that x squared is greater than or equal to 0.
Then I would have wanted from negative 3 less than and from positive 2 greater than. It would have been an or statement. Exactly. Yes. Well, this is an and statement. That's what an and statement looks like. Because I want everything between here and here. Okay, yes. Well, because between negative 3 and positive 2, those are the solutions. This test point works. I want them between my zeros become my boundaries. Do I want them between those two values or do I want them on the outside of those two values? You test in between the zeros and outside the zeros. You don't test the zeros because zeros give you 0. An or statement? Make sure you check it. They haven't done a math error, but generally that's how it works, yes. So if in between doesn't work, then outside works. If outside doesn't work, then in between generally works. All right, let's do the same problem algebraically. Algebraically is the same thing as a chart in my mind. You're just setting up a number line with our zeros. Our zeros were -3 and +2. Solid here and solid here. Why are they solid? Because it's equal, right? If it had been strictly greater than, what would I put on those? A circle, an open interval. I still have to do test points. So I still have to do my test points. I'm going to let x equal -4. Well, we know, what did we get when x is -4? We got 6, which is it less than or equal to 0? No. All right. So we don't want here. We tried x is equal to 0, and we got -6 is less than or equal to 0, right? We did all this work up earlier, right? So this one works, right? That means, oh, I like that. I'm in between. Okay, we tried x is equal to 3. What did we get here? 6 is less than 0. That doesn't work. That doesn't work. This one did work. I'm not doing the work over again, right? Because we already did it up above. Well, they'll give you a few problems to do algebraically, a few problems to do using a chart, and then this last way is using a graph. Okay? All right, graphically.
So we just put that little split over.
Yeah. I don't know if I had you do it. Where's the... Oh, okay. All right. Okay, so then this is graphically. And again, you got to factor. So no matter what case you do, you're factoring. Okay? Remember, this is a quadratic, so the shape is a parabola, yes? Okay, where are the zeros? -3 and +2. This equation was still the same. What was it? Read it to me. X squared -6 less than or equal to. Okay, so solid, solid, yes? Okay, I want negative. Can you please tell me how, if this was a parabola, would this parabola open? Up. I could care less in this case where the vertex is. All I need to know is it's something like this, yes? Can you show me where does the graph have negative y values? Aren't all these the negative y values? And doesn't that fall between your zeros? So in either case, I get x is less than or equal to 2 and greater than or equal to -3. What y values are these? These are your positive y values. Down here, because look, isn't y positive up here and negative down here, right? And isn't this going to be positive y values again? So I wanted negative. I want the part of the graph that hangs below the x-axis. It hangs below the x-axis between the zeros. Your options are either between the zeros or outside the zeros. And so those are your three methods. Right. Mm-hmm. Yeah.
So if it opened down,
Right. If it opened down, then the negative values are here. It's the outside, right? It's not inside, because in between this gives me all the values above, right? Does that make sense? All right, so try this one. Use all three, yeah. I don't know why it stopped B. So this is graphically.